Okay, so like we said, 137 marks, 50 multiple choice, 15 written. Make sure you don't spend too much time on a question you don't know how to do. Okay, just move on. Come back to it later. Okay, don't leave it blank, but come back to it later. But yeah, definitely the first time through, put a star beside the questions you're confident about. Okay, and do them first, especially on a final exam. I know I had a organic chemistry final in university, and I got absolutely owned by it, but so did everybody, luckily. The first time through a 27 question organic chemistry final, I knew how to do 6 questions of the 27. And I did them because I was like, well, I got to do the ones I know how to do. I don't know anything about these other ones. So I wrote those ones down. And then as I read through the ones I knew how to do, it triggered a few things. And the second time through the test, I had, I think, 12 done of the 27. Okay. Third time through, I had something written down for 15 or 16 of the 27 questions. Okay. Fourth time through the test, I think I had something written down for about 20 of them. Okay. End of the test, I had something written down for every question. Not necessarily very good, but I had something written down for every one of them. Okay, but start with the stuff you know. It'll get your confidence up. It did for me, even though it was only 6 out of 27 questions. Okay, and unfortunately, I didn't. The first question I knew how to do was like question 15. It's a little disconcerting to go through 14 questions and not have a clue. Okay, but in the end, I got 37% on that, and I'm proud of that because that was 5% higher than the class average. Yeah. The curve works for you sometimes. They grade on this thing called the curve. So as long as you do better than half the class, you pass. It's pretty sweet. Yeah, pretty much. Yeah. If you get around the class average, you get like, it was a 9-point scale at that time, you get like around a 5 out of 9. That's a pass. I never passed a single exam in that course. Passed the class. Because I did better than the rest of the people taking that class. Well, not all of them. There were some really smart people kick my butt, but they don't matter. Okay, so yeah, do the ones you know how to do first, because that's helpful. Okay, all right, distribution here. There's 16 multiple choice on chemistry, and the topics included in those multiple choice questions will be atomic theory and structure. Okay, naming compounds. There's actually a fair amount of that. And do you need to know how to name and write the formulas for compounds to do the stuff that's going to be in the written? Like writing chemical equations, predicting equations, mole equation. Right? You got to be able to do formulas. If you can't, you will never be able to do those. So it is advisable for you to review, especially your ionic rules. Okay? For naming and writing the formulas for ionic compounds. Okay? It's important to review that stuff because if you can't write the formulas or the names, you can't do the stuff that's worth big marks. Okay. Properties of compounds, we did a lab on that, right? The conductivity, solubility, physical, observable physical properties, pH, that kind of stuff. Okay, there's some stuff on solubility, possibly involving the use of your solubility chart. Okay, physical and chemical changes. Right, there's some stuff in there, telling the difference between a physical change, a chemical change, signs of each, okay, stuff like that. Things we did in our labs. Okay. There's 11 multiple choice on biology. Okay, and in those 11 questions are parts and functions of the cell. There's stuff on plant growth and development. That could include hormones and tropisms and things like that. Okay, and then there's a couple on multicellularity. Yeah, everything's in order. So there's 16 multiple choice questions on chemistry. Start off the test. Then it goes Unit 2, biology, and there's 11 questions on biology. So you can get your train of thought. All right? Okay. 12 multiple choice on physics, covering topics like mechanical energy and work, obviously the most important thing in physics. Okay, laws of thermodynamics. There's probably 6 of those. No, 5 of those are on graphing. So there's some graphing in the multiple choice, big time. Okay, scalars and vectors, some simple V equals D over T calculations, and some stuff on efficiency. Okay, and there's 11 multiple choice on global systems. There's stuff in there about soils, biomes, climate, factors and components or both. Okay, heat capacity and wind patterns. Okay, written response. There are 4 written response items on chemistry, and several of those have an A and a B part. Okay, so it might say like question 3, predict the products of the following reactions. A, and then B, you'd have 2 of them there. Okay, if there's one on balancing, there'll probably be like 3 or 4 equations to balance, so there'll be an A, B, and a C, right? Stuff like that. All right, the stuff that's going to be in there, okay, balancing equations, writing and predicting reactions, and mole equation calculations. The most important skills you've got to be able to show for Chem 20. Okay, there's 4 written on biology, and they involve plant transport, cell size and function. So the big theme would be transport. Okay, almost all of the written response stuff from bio involves transport of some kind. So make sure you go over the big 3, osmosis, diffusion, and active transport, okay, as well as how a plant transports material, possibly using some of those. Okay, there's 4 written on physics, work energy theorem problem, graphing question, acceleration problem, conservation of energy problem. Right faster. 4 written on chem, many with A and B. Mark, put the phone away. Okay, 4 written on physics, like I said, work energy theorem, graphing, etc. Okay, and then you've got 3 on global systems. And they're basically the same questions you had on your unit exam. There's going to be a climatogram. Tell me where it belongs. Okay, an energy transfer application question like the Quinsey question. Okay, and a heating curve problem. Okay, that should give you a pretty good idea of where to spend your time over the next 4 days. Now, how many of you have an exam in the next 4 days before science? Okay, what is it? English and social. Okay, religion and math, right? So it's a different thing for all of you. Okay, guys, you need to be hunkered down over the next 4 days, okay? Honestly, your main priority over the next 4 days needs to be spending copious amounts of time studying. There's no way around it, okay? You do need to take breaks. I'm not saying study from dusk till dawn, or dawn till dusk, whichever suits your sleeping patterns, okay? Or 24 hours a day, because you shouldn't do that either, okay? But you need to be spending the majority of your day for the next 4 days studying. You have lots to cover. Okay? When you're studying, do take little breaks. Little ones. Okay? That doesn't mean like go and watch a 3-hour movie. Okay? That gobbles up a lot of time. Okay? Take your little break, check your social media on your phone for 15 minutes, then put the phone away. Okay? And then go back to work. Your breaks, realistically, you should be doing something active during your breaks. Okay? Because you're not going to be active while you're studying, most likely, unless you're listening to one of my podcasts while on a run. Not a bad idea, actually, because then you're killing 2 birds with 1 stone. Okay, it's just you'll be using your data because you won't be on Wi-Fi unless you're at the gym. Okay, but yeah, it's something to think about. So yeah, just make sure that you're doing that stuff. Other little strategies for you to think about. Look at your quiz marks. Okay, go into your Power School, look at your quiz marks. Any quiz you didn't do well on, go down to the bottom of that quiz, and in the details for that quiz is a link to the podcast where I went over that quiz. Especially quizzes on things like predicting equations, mole equations, physics problems, work energy theorem, okay, that kind of thing. Use the podcasts. You don't need to watch every podcast in its entirety. You would have to not sleep for the next 4 days to probably do all of them, so don't. Okay, watch the parts you need to watch. Okay, that's what they're there for. That's what they were designed for. They were never designed to replace being in class. Okay, oh, I just don't have to show up for the rest of the semester. I'll just watch it at home, then go to St. Paul's. Like that's not the Center for Learning at Home works like that. Not here. Okay, so make sure that you watch the ones you need. Okay, and come and see me tomorrow between 9 and 3:30, and Thursday between 1 and 3:30. Okay, I'm here to help you guys, so make sure you come in. Taylor. No, I never do, because I can never use one of those questions again. You can come in and look at your unit tests if you want. Okay, so tomorrow and Thursday, you want to come in here and look at your unit tests, I'll dig them out. 9 to 3:30. Boy, I dislike repeating myself. Global system, oh, multiple choice, okay. Not far enough, farther. Okay. So those are some things that you should definitely do. If you haven't started doing the review package I gave you, you should definitely start that. That should not be the extent of your studying, however. Okay, just doing that review package is not sufficient to prepare for this test. Okay, you need to do more than that. Reading your notes is valuable. It is more valuable for global systems and bio than it is for physics and chem, because physics and chem, as you can see, the questions are basically skill-based, being able to show me you remember how to do certain things. Okay, so make sure you focus on practicing things for chem and physics and knowing things for bio and global systems. So the studying for those is a little bit different. Look over your labs. Okay, you got those on your Google Drive. Okay, they will be there until, I don't know, probably August when I start deleting things. Okay, obviously you won't need them after Friday, but they'll be there until then for sure. So look over those. Yeah, come in and look at your exams. That's not a bad idea either, but okay, you should be spending a fair amount of time each day, guys. Now, on exam day, actually, let's say night before the exam, you should obviously be studying, but not all night. You need to get a good night's sleep. Okay? Believe it or not, being well rested is probably more important than cramming. The cramming isn't going to help you at that point. If it's 2 o'clock in the morning and you're thinking the next 4 hours are going to be your most crucial studying time, you could not be more wrong. You will not remember any of that stuff. Your mind is tired, no matter how many Red Bull you drink. Okay? Your mind is tired. And when you're cramming, you're not putting anything into your long-term memory. It's all going to short-term, and you're going to forget it. And you know when you're going to forget it? When you open your test up. Anyone ever had that sensation? You look at a test and you blank? It's because everything you had studied was in your short-term memory. And under stress and after a certain amount of time, your short-term memory erases itself and reformats. to retain new information. If that was where you had recorded everything, you are in deep, deep trouble. Okay? And what usually happens is right after that, you have this cataclysmic failure. Okay? Not, I mean, like on the exam, but I mean, now you start to stress because, oh God, I don't remember anything. What am I going to do? What am I going to do? And you just freeze, and your stress overwhelms you, and then you can't access your long-term memory because you're too stressed. Okay? So get a good night's sleep. Okay? Study well in advance. Don't leave it for the night before, or that is what is going to happen to you. Okay? So make sure you do that. Get a good breakfast before you come in here. All right? Black coffee and cigarettes is probably not the breakfast of champions to be having before you come in and write your final exam. Okay? So make sure you have something good. Okay? And bring in some water, okay? Or whatever drink you want to have, as long as it's in a resealable container. Okay? And an exam appropriate snack, not the Costco sized bag of Doritos. Okay? Everybody with me there? Okay, so those are things that you should keep in mind as part of your preparation. Okay, remember also you need to be here 8:40ish. Okay, we'll begin loading the exam writing area, the gym in this case, at 8:45. Leave your cell phones elsewhere as they can't come in. Okay, and make sure your calculator's got fresh batteries, 2 pencils, 2 pens, eraser. Okay, and that's all you need to bring. 12:45. I was literally going to lose my mind there. Okay. Like, there were several heavy objects within reach. Okay. All right. Last thing. Your exam, when you get into the exam, it already has your name on it, right? So you go in there, you look at what rows my classes are in. You go to the row that has your name in it. Okay. Look for your exam. Sit down at that desk. When you open up the test, one sheet is not stapled. Okay, there's a sheet that is tucked into the exam. The reason for that, it has your multiple choice answer form, as well as all of your formulas on one side. And on the other side of that sheet that's tucked into the exam is your periodic table. And it's in full color. It's exactly like the one I gave you, except it's on an 8.5 by 11 normal size sheet of paper, not the big one. Okay, because I'm not, it's just, well, too bad. Suck it up, buttercup. Okay? Then, on the back page of the exam, stapled, okay? The last page of the exam, on the very back, is the solubility chart. Okay? I put it there because you only need it for a couple of questions. Don't tear it off, because on the other side of that are the last 3 questions in the written response for the test. Okay? If you rip that sheet off, you may forget to do those 3 questions. All right? So don't tear that one off. Okay, everybody with me on that one? So keep that in mind. Okay, those are the things that you will have given to you in the test. Okay, remember you have 2 hours to write the test. There's no extra half an hour. This is a 2-hour test. Okay, I know that English and social say it's a 2-hour exam with an extra half an hour. That's a 2.5-hour exam. Okay, I don't know what this extra half-hour crap is all about. It's dumb. Okay. It's either a 2.5-hour exam or it's a 2-hour exam. The diploma exam is the same thing. You have 3 hours with an extra half hour. Then you have 3.5 hours. Okay? You have 2 hours, or you have an hour and a half with an extra half hour to write my test. I don't care how, that's how long you have. Okay? 2 hours. Unless you have an allotment for extra time through learning support, in which case you're not writing in the gym anyway. Okay? You're writing in learning support, so that's different. Okay? Now, remember, you need to watch the time. Okay? Watch the time, because at 11 o'clock, that's it. We come around and take the tests. Okay? It would be nice if you surrendered it willingly, but I am fully willing to wrestle it away from you also. Okay? I've actually had to do that in the past once or twice. Did you know that if someone died during an exam, every student automatically... Who told you that? Well, Google doesn't know everything. If someone dies during this exam, we'll just cart their body away and you can keep writing. Okay? Hey, if you're the one who died, Okay, your problems are over. Okay, but if you're not, you still got to write your test. No one's gonna die during the test. That's the dumbest thing I've ever heard. Okay. Okay. Last couple things, guys. Okay. Last couple of things here. Um, we already said that you should be onto the multiple choice by at the very latest, like 10:35, 10:40. Okay. Keep an eye on that. And remember, do the ones you know how to do first. Okay. That's crucial for managing your time effectively on a test. Do the ones you know you can do first. If you have a unit that you felt more confident in, do that unit first. Okay? There's nothing saying you got to do the test in order. The only thing you have to do in order is make sure that you fill in question number 5's answer on the multiple choice and question number 5's row. Okay? If you do them out of order, make sure you're not doing question 12 for number 1. Okay? That isn't going to work out very well. Okay? That's the only thing you got to watch. If you don't do it in order, make sure that you're keeping track. Okay? All right, you guys got questions? Mole equation, I knew it, because you know what? That's the one that always gets asked. Guess what? It got asked this morning, too. Okay, so mole equation. N equals little m over big M. Here's what everything stands for. N is the number of moles. In, you guessed it, moles. Okay? Little m is the mass in grams. And capital M is the molar mass in grams per mole. That's the one you get from the periodic table. All right? You're never going to use the mole equation to solve for big M because you can always get it from the periodic table. All right, example. What's the mass of 1.7 moles of calcium nitrate? All right? The most common mistake people will make is forgetting how to write the formula for an ionic compound containing a polyatomic ion on that question. Swap and drop. Okay? So the first thing that question gave me was the number of moles. Okay, that's right here. N equals 1.7 moles. And then they told me, here's the material, calcium nitrate. When I swap and drop, calcium's a 2 plus, nitrate's a 1 minus, so the 1 goes here. We don't write 1s. The 2 goes over here. I have to put brackets around that so that I know there's 2 nitrates, which means there's 2 nitrogens and 6 oxygens. Okay, that's important when you're calculating the molar mass. Okay, because we would go 40.08, that's our 1 calcium. 14.01 times 2, because there's a nitrogen here, but there's 2 of them. Okay, and 16 times 6. That is our 3 oxygens times 2, so 6 oxygens there. All right, we add those up, we get 164.1 grams per mole. Okay, so again, being able to write the formula is crucial. That basic skill influences your ability to demonstrate the higher skills. All right, if I want to calculate the mass, then I've got to manipulate the mole equation for little m. So I multiply both sides by big M. Big M cancels here. 164.1 times 1.7 gives me 278.97 grams. Okay, so that would be like the second easiest type. There were 4 types, if you recall. Okay, one of the more difficult types, not because it's harder, but because it involves an extra step, and that is the use of Avogadro's number, would be one like number 2. How many molecules of water are in 250 grams? Okay, now, again, they told me the material I'm dealing with is water, so I got to do the molar mass. Water has 2 hydrogens, so 1.01 times 2, and 1 oxygen, 16, gives me a molar mass of 18.02 grams per mole. The other thing that they gave me, okay, was the mass, 250 grams. So that's my second given. If I want to find the number of molecules, I need to know the number of moles. That way, I can multiply the number of moles by Avogadro's number, which is the number of particles or molecules in a mole. All right, that's 6.02 times 10 to the 23. That's how many molecules are in a mole. Okay. So the first thing I do is solve for n, because I have little m and big M. 250 over 18.02 gives me 13.87 moles of water. And then I take that and I multiply it by Avogadro's number, remember that on your calculator, that needs to be in brackets, and you press the EXP button, okay, to get this, and then 23. Okay. And that gives me 8.35 times 10 to the 24 molecules of water. Okay. I did 4 of those every day for a week in that unit. Okay, starting with it's lesson 21, the mole equation, and there's parts like 1, 2, 3, and 4, okay, in there. So if you're wanting to watch podcasts of me solving each and every way that that can be asked, that's where you need to go. Okay, making sense there? Yes, that'd be a written response, because I want to be able to give you part marks. Yeah. Okay, other questions? It's lesson 21. Unit 1, lesson 21, the mole equation. Okay, also guys, since we didn't get to do a lot of review, I mean we still have about 10 minutes here, but we didn't get to do a lot of review, I am posting the 2 final exam review podcasts I had from last semester, because we had 2 full classes last semester to do that, so I will post both of those. They're already on YouTube, but I'll put links to them on Google Classroom so you can watch them. There's quite a few questions that we do review stuff in there. That's probably worth watching if you want. Okay, just ignore the stuff about how many questions are on the test and all that, because this is a different test. The numbers are about the same, but I think I had 1 more chemistry question or something like that. So it's a different test. Okay, still asking the same stuff. So the review part is still valid, but they're different questions. Okay. Okay. What else do we want to talk about? Multicellularity. Okay. So the questions about multicellularity, guys, the big thing for that is going to be why. Okay, why is multicellularity an advantage? And that comes back to cell size, surface area to volume, okay, the cube lab that we did. If you become multicellular, you're made up of small cells, but you can be big, okay, and still transport material effectively, whereas a big single cell can't do that. So, okay, the other thing was when you're made up of many cells, some groups of cells are specialized to do a certain job. They do it more effectively, but there has to be that intercooperation, okay, between all the cells. Yes, okay, why can't a cell be bigger than an organ? Because, again, surface area to volume. If a cell is really big, it has too much volume, and diffusion is the only way to transport material through the cytoplasm of the cell. Diffusion is not targeted, and it's slow over large distances. So if a big cell won't be able to move stuff effectively to where it's needed. Yeah. Okay, what else? Combustion reaction? Yeah, you have to predict the products, right? So if I gave you a question like, and said, small 2, okay, and said, predict the products, I'd need to know that's a combustion reaction. The products of a combustion reaction are always this, right, and then do my balancing, right? Remember that there were special balancing rules for this, right? This is an even number, so I start with a 2, the rule of 2, and then do it alphabetically. So 12, okay, 28, and then oxygen's over here, 24, and 14 is 38, 19, right? Going like that. Whereas if I gave you this one instead, so let's go, okay, I need to remember that that's a synthesis reaction. And in a synthesis reaction, okay, the atoms go together to make a single compound. What kind of compound is that? Ionic or molecular? It's ionic. It's got a metal in it. Metal, non-metal is ionic, which means it's got to be dropped and swapped. -3 plus 2. Okay, so now I got to go back here and go, right, this needs a 3 here. Okay, you need to remember which ones are special, although again, those will be color-coded on your periodic table. Yep. Yeah, so what Silver Rose is asking there is, yes, I put a 2 on nitrogen here, but not because nitrogen comes as a 2 by itself, but because that's what the swap and drop said to put there. Do it like a reaction with, okay. Okay, what kind of reaction is that? Nope. It's a double replacement reaction. Okay? I don't have a carbon containing compound reacting with oxygen, and I've got calcium carbonate ionic with hydrogen nitrate ionic. Okay? In a double replacement reaction, I swap the metals. So that means calcium's new partner is nitrate. Okay? Hydrogen's new partner is carbonate. And both of those are ionic, so what do I have to do with both of them? So I got to drop and swap. Okay, this is a +2, this is a -1. Okay, so I got CaNO3, 2, and then this is -2, and this is +1, so I got H2CO3. Now I got to balance the reaction. So what should I balance first? The biggest number. Balance what's present in the largest number first. I'm going to say, let's do nitrate first. Okay, I've got 2 over there, so I need a 2 here. That gives me 2 hydrogens. That works out pretty well because there's 2 over there. Okay, there's 1 carbonate over here, 1 over here, 1 calcium, 1 calcium. Looks like that's all we had to do. We just did that. Yeah, we just did that. Right there. We just did that one. Just I want to give everyone a chance. We've already done a question like that. I think in the 50 multiple choice questions, there's one that involves a person's name. And it's obvious. It's obvious who it is. So, yeah. Okay. What else, guys? Okay, well, since no one else has got a question, I'll do another mole one there for you. But I'm going to do it this time with one where I give you the number of molecules. Because I already did one where you find it. This way you get one where you're given it. Okay, so I'm given the number of molecules of sodium nitride. Okay, first thing I should do is get big M for sodium nitride. Na with N, -3 + 1. So we're looking at Na3, N for that. Okay, and so that's going to be 22.99, is that right? I think so. Times 3, okay, plus 14.01, 1 nitrogen. All right, so 82.98 is my molar mass. Okay, grams per mole. Now, if I want to find mass, I need little n, or I need n, sorry, and I need big M. I have big M, but I don't have n. Well, the number of moles is the number of molecules, okay, divided by Avogadro's number. Because Avogadro's number is the number in 1 mole. So if I take how many molecules I have and divide by the number in 1 mole, that leaves me with the number of moles. Okay, so we'll take our 2.5 times 10 to the 24 and divide that by 6.02 times 10 to the 23. Okay, so that gives us 4.15 moles. Okay, and then we multiply that by the molar mass. Okay, all right, good luck on all your tests, guys. Hopefully we'll see you tomorrow or Thursday at some point, but if not, we'll see you Friday morning. Okay.